Alright, so in this video, I'm going to be proving to you guys that pi is equal to 3. So as you guys probably already know, pi is an irrational number, meaning it doesn't have a whole number value, and it's actually equal to 3.14159 and on and so forth forever. So that's why it's an irrational number. It's that just don't stop going. So in this video, I'm going to be proving to you guys that pi is actually equal to 3 and not the irrational number that we all know it is. So what I'm first going to do is start with the statement x is equal to pi plus 3 over 2. So all I'm doing is I'm giving a value to a variable, which is completely legal. So now what I'm going to do is multiply both sides by 2. So I get 2 times x is equal to pi plus 3 over 2 times 2. Now, 2 times x is equal to 2x. So I get 2x is equal to, these two 2's cancel out, pi plus 3. So I get 2x is equal to pi plus 3. And now, from here, I'm going to multiply both sides by pi minus 3. So I have pi minus 3 times 2x is equal to pi plus 3 times pi minus 3. Now, pi plus 3 times pi minus 3, I'm going to distribute the pi, so I get pi squared plus 3 pi minus 3 pi, which they just simply cancel out, plus 3 pi minus 3 pi. These two cancel out. And then I have minus 9 at the end. So this is, I can just say this is pi squared minus 9. And for my left-hand side, I can distribute the 2x, so I get 2x pi minus 6x. And now from here, I'm going to add x squared on both sides. So I have x squared plus 2x pi minus 6x is equal to pi squared minus 9 plus x squared. And let me just reorder this real quick. I'm going to write this as x squared minus 6x plus 9. So I'm going to add 9 on both sides is equal to x squared minus 2 pi x. So I'm going to subtract 2 pi x on both sides. And at the end, plus pi squared. So I have x squared minus 6x plus 9 is equal to x squared minus 2 pi x plus pi squared. And now, x squared minus 6x plus 9, this factors out into x minus 3 squared. And x squared minus 2 pi x plus pi squared is the same thing as x minus pi squared. So I have x minus 3 squared is equal to x minus pi squared. And now, I want to cancel these two squares, so I'm going to take the square root on both sides. So now the square root of x minus 3 squared is equal to x minus 3. And the square root of x minus pi squared is equal to x minus pi. So I get x minus 3 is equal to x minus pi. So now I'm going to cancel these two x's out by subtracting x on both sides. So now I get negative 3 is equal to negative pi. And now if I multiply both sides by negative 1, I get pi is equal to 3. So there you have it. I just proved that pi is equal to 3. So now where did I go wrong? Because obviously we know that pi is not equal to 3. So where did I go wrong? Well, I actually went wrong on this step right here, where I said that the square root of x minus 3 squared and the square root of x minus pi squared is equal to x minus 3 and x minus pi respectively. Well, this is actually not true, the square root of x minus 3 squared isn't equal to x minus 3, is equal to the absolute value of x minus 3. And same goes with the square root of x minus pi squared. It's not equal to x minus pi. It's equal to the absolute value of x minus pi. So the reason this is so important is because now I get x minus 3 is equal to negative x minus pi. Or also negative x minus 3 is equal to positive x minus pi, since we're taking the absolute value of these two. So if we want to solve x minus 3 is equal to negative x minus pi, we're going to have to first distribute the negative sign. So I get x minus 3 is equal to negative x plus pi. So now if I add x on both sides, these two cancel out. So I get 2x is equal to 3 plus pi. And x is equal to 3 plus pi over 2, which, going back, is what we started with. So there you have it. That is something really important to know, that the absolute value is, the square root of a square isn't just the normal version, it's the absolute value of that. So in this video, I'm going to solve the problem 2 to the power of 19 minus 2 to the power of 18. So I want to find the value of this problem. So for my solution, I'm going to start by rewriting my problem here. So 2 to the power of 19 minus 2 to the power of 18. And to start off, I'm going to rewrite 19 here as 18 plus 1. So I get 2 to the power of 18 plus 1 minus 2 to the power of 18. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 18 plus 1 is equal to 2 to the power of 18 times 2 to the power of 1. And now I have this minus 2 to the power of 18. Now from here, because I have two terms that are the same, I can factor out 2 to the power of 18. So I get 2 to the power of 18 times, 2 to the power of 18 times 2 to the power of 1 divided by 2 to the power of 18 is simply just 2 to the power of 1, and negative 2 to the power of 18 divided by 2 to the power of 18 is negative 1. So I get 2 to the power of 18 times 2 to the power of 1 minus 1. And this is equal to 2 to the power of 18 times, 2 to the power of 1 is 2, so I get 2 minus 1, which is equal to 2 to the power of 18 times 1, which is equal to 2 to the power of 18. So I get 2 to the power of 18 as my answer. Now, there is actually another method of solving this problem. So going back, our original problem was 2 to the power of 19 minus 2 to the power of 18, right? And what we did was we wrote 19 as 18 plus 1, and we solved it by factoring out 2 to the power of 18. So now, what if instead of rewriting 19, I rewrite 2 to the power of 18 as 2 to the power of 19 minus 1. Now, the way I'm going to solve this is I'm going to rewrite 19 minus 1 as 19 plus negative 1. Now, I can still use that property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 19 plus negative 1, that's going to equal 2 to the power of 19 times 2 to the power of negative 1. So I can still do it. Now from here, my The greatest common factor from these two terms is 2 to the power of 19. So I get 2 to the power of 19 times 1 minus 2 to the power of negative 1, which is equal to 2 to the power of 19 times 1 minus 1 half, which is equal to 2 to the power of 19 times 1 half, which is equal to 2 to the power of 19 times 2 to the power of negative 1. And 2 to the power of 19 times 2 to the power of negative 1 is equal to 2 to the power of 18.